Okay, so this video is going to help you on page 83. We're going to break apart vectors to find their component forms so we can add them. So at the top of page 83, we're given some vectors. We have vector W, and they tell you that it has an angle of 75 degrees, and that its magnitude is equal to, 10 centimeters. So let's break that down. So when you were in physics, if you've taken physics, you learned that the x part was magnitude cosine angle and magnitude sine angle. And if you haven't taken physics, let's just think back to when we did some trig. You would tell me that x over r equals cosine of theta. That's the definition of my cosine. So if I wanted to solve for x, or I wanted to find the x piece, I would do x equals, and I'd multiply the r over and get r cosine theta. I do the same thing with sine, the y over the r equals sine theta, and so I would get that y equals r sine theta. These are two really good formulas that we should remember, because I want to find my x and y pieces. So on vector W, if I want to find the x piece, I'm going to do r, which is my magnitude, it's my radius, it's this piece that would have been on the circle. I'm going to draw really quick. So if I had the circle, this length, this magnitude right here that I had that was 10, it's my radius. So I'm going to do 10 cosine 75 degrees. I'm going to put it in component form. I'm going to do 10 sine 75 degrees. I'm going to use a calculator. I'm going to type these both in. So give me a second. Let me grab my calculator, pause the video so that you can type these in your calculator as well. You're going to type them separately. You're going to type this one, press enter, and this one, and press enter. So when you type 10 cosine 75, and I put my degree symbol in, you should have got 2.588, comma, 9.659. So this is the component form of vector W. So I'm going to write that down on my paper in front of me real quick. And now we're going to do another vector. We're going to do, let's do vector V next. So vector V is, the theta is equal to 60 degrees, and my magnitude of vector V equals 4 centimeters. So if I want to find its component form, I'm going to do 4 cosine 60 degrees, and then 4 sine 60 degrees. I'm not going to touch my calculator yet, because I know that the ordered pair at 60 degrees is 1/2, comma, root 3 over 2. So this would be 4 times 1/2. And then this would be 4 times root 3 over 2. So now I might have to use a calculator. I got this root 3 over 2. Half of 4 is 2, comma, half of 4 is 2 root 3. And then I'm going to type in my calculator this 2 root 3 just to get an approximation of a decimal. So the component form of W is 2, comma, 3.464. So we want to write those down on our paper. And the last one we need to do is vector U. Vector U says that its angle is 135 degrees. And the ordered pair on the unit circle is negative root 2 over 2, comma, root 2 over 2. Not all of these are pretty unit circle ones, but the ones that are, I'm just going to review the unit circle. The magnitude of vector U is 6 centimeters. So I'm going to do 6 cosine 135, comma, 6 sine 135. So that's really 6 times negative root 2 over 2, comma, 6 times root 2 over 2. So my numbers are going to be the same, but the x part, because it's in the second quadrant, 135 degrees is in the second quadrant, is going to be negative. So my answer is going to be negative 4.243, comma 4.243. So let's write those on our paper. So I did all that math up top on the top half of the paper because now I'm going to move on to the bottom part of the paper. So we've done all this math. So we want to do number 1 now. Number 1 says vector v plus vector w. So to add vectors, you have to add the x's and add the y's. So vector v was 2, 3.464, and vector w was 2.588, 9.659. So to add these, I'm going to add the x piece with the x piece and the y piece with the y piece. So when I add these two together, you're going to get 4.588, comma, I'm going to use my calculator for the other part. And you should get that it is 13.123. So this is my resultant vector, the thing that you'd write on the line where it says the magnitude. Oh, sorry. So now I need to find the magnitude. So this is my vector. This is vector v plus w. To find their magnitude, you take each piece, you square them in square root. So you do 4.588 squared plus 13.123 squared, add them in square root. So I'm going to type it all in my calculator at once. So under a square root on my calculator, I put the square root first. I put parentheses and typed 4.588 squared, and then plus parentheses 13.123 squared. So the magnitude of this vector is 13.902. And then to find the angle of the vector, because it wants to know the angle of this vector, you're going to use this right here, this component form. You know that tangent of theta equals the y over the x. So if I want to find theta, I do arctan of y over x equals theta. I just need to be very careful when I do this and make sure that my signs match up. And let me show you what I mean. This is a positive, this is a positive, so I'm going to be in quadrant 1. So when I get my theta down here, I need to make sure the theta I get is in quadrant 1. So in my calculator, I'm going to type arctan of my y, my 13.123, over my x, my 4.588. If your calculator's in degrees, it'll spit out a degree answer. And if it's not, you'll have to take your answer you get and multiply by 180 and divide by pi. Either way is equivalent. So I got my theta equals 70.73, it's going to round up. 70.73 degrees. So this is the answer that goes in your degree line, and this is the answer that goes on your magnitude line, and this is probably in your work where you added this up because you had to find this to find this and to find that right there. So let's try one more. So I'm gonna do number 4. Let's do number 4. Looks difficult and a little bit challenging, and I think we can handle it. So number 4 says I'm going to do 2w minus u. So the first thing I have to do is this 2 part. So I have to do 2 times vector w. So 2.588, comma 9.659. So when I multiply that 2 in, I'm going to get my new answer. So I use the calculator, I get 5.176, comma 19.318. And then this, grab a different color. This w is being subtracted, so I'm going to have to distribute a negative sign into it. So it's going to be minus w, which was negative 4.243, comma 4.243. And so this negative is going to get distributed in. So what I'm really going to end up adding is my 5.176, comma 19.318 plus a positive 4.243, comma negative 4.243. And then I'm going to kind of walk you through it and let you finish this one because I'm going to go back and do number 3. You're going to do your x's plus your x's and your y's plus your y's, and then do the same thing I did in the last problem in number 1 on the previous slide. Find your magnitude and find your angle. If you need a little bit more help doing that, let's go on and go backwards 1 and do number 3, and there's a reason I want to do number 3. So number 3 says that I'm going to do v plus u. So vector v is 2, comma 3.464 plus vector u was negative 4.243, comma 4.243. So when I add these together, I'm going to do the x's plus the x's and the y's plus the y's. So you're going to use your calculator or use your brain and do 2 plus negative 4.243, which we should have known was going to be, oops, let me stay in blue, negative 2.243. And I'm going to use my calculator and do 3.464 plus 4.243. And you're going to get 7.707. So here's my new vector. To find its magnitude, I take each piece, I square it, and I square root the whole thing. So I'm going to do the square root. So to find the magnitude, the piece that says vector v plus u, I'm going to do, use your parentheses. You have to, you're going to throw an answer. Parentheses, negative 2.243 squared, because this way when we square it, it becomes a positive, plus 7.707 squared. And then I'm going to square root the whole thing. So my calculator, I'm going to put a square root, parenthesis, negative 2.243, close the parenthesis, squared, plus, stay under the square root, put another parenthesis, 7.707, close it and square it. So the magnitude of this vector is going to be 8.027 because it rounds up in their centimeters. This is the part earlier that I was warning you about, to find the angle. So to find my theta, this is this tricky piece right here. So we know that tangent of theta equals y over x. So I'm going to do arctangent of my y, my 7.707. Never wrote the 7 up there, sorry. Over negative 2.243. Equals, and before I write down what it equals, this is what I want to point out. This new vector that we have right here that we have added together and formed, this x is negative and the y is positive. So the quadrant that I should be in right here when I get my answer is quadrant 2, because x is negative and y is positive. So I'm going to grab my calculator and I'm going to type, I'm going to grab that arctan from the trig button, I'm going to put my fraction in, I'm going to put 7.707 over negative 2.243. If your calculator is in degrees, then your answer popped out. And if your calculator is in radians, you have to multiply by 180 and divide by pi. And so you're going to get an answer that a theta equals negative 73.773. That's down here, guys, but we want to be over here. And here's what happened. We used arctan. Because we put an arctan on the paper, we restricted the hot lava. We can only get answers in quadrants 1 and 4. We used an arctan. Arctan was not originally in the problem. So because we used a tool, we have to unuse the tool. So I need to find an angle that would be on the bow tie system. with negative 73.773, but it has to lie in quadrant 2. And so this is what we're going to do. Instead of being down here, I want to be over here. So if this distance here is negative 73.773, then this distance right here also has to be the 73 distance. So I'm going to take 180 because the whole first two quadrants is 180. Oops. 180. And I'm going to subtract away the 73.773. I am not saying by any means that you always do 180 minus. What I'm saying is that I am logically unusing the tool that I use to find the right angle in the proper quadrant. So when you do that, you get your theta equals 106.227 degrees, and that is in the second quadrant. So we have one answer right here, we have another answer right here, and this was the vector that we had when we added them together. So you're going to go to page 85, and you're going to do problems. Let's do problems 3 and 4. So you'll do problems 3 and 4. Actually, no, take it back. You can do any two problems that you want, and you're going to take a picture of those two problems and submit them to Canvas.